Okay, now the next question is from O Level 2009, Paper 1, Question 6. Now the proton number of element X is 6. The proton number of element Y is 9. What is the formula of the compound formed between X and Y? Now actually you can find out from your periodic table what are these elements X and Y. Proton number 6 and 9. Proton number is the bottom number. So your proton number 6, which is X, your X is actually carbon. Your Y is actually fluorine. And both carbon and fluorine are non-metal. Now non-metal and non-metal element combined together, that one is a covalent compound. Okay, non-metal combined forms a covalent compound. Covalent compound means sharing of electron. So we know that this compound is a covalent compound and it is formed from the sharing of electron. Now this X, you can draw the dot and cross diagram. So this would be your X. Your X is actually proton number is 6. So 6 means that the electronic configuration is 2, 4. Your Y is 9, means that the electronic configuration is 2, 7. So 2, 4 means short of 4 electrons. 2, 7 means short of 1 electron. Now short of 4 electron means that it needs to share 4 pairs of electron. Because every time it shares 1 pair of electron, it gains an additional electron. So in order to reach to 8, it needs to share 4 pairs of electron. Who can it share with? It can only share with Y, because there are only X and Y. It cannot share by itself, it must share with Y. So you draw Y, it must share 4 pairs of electron. Y, Y, 3 and then 4. Okay, and then you can, the dot would be the valence electron. So the dot would be valence electron of X. The cross would be valence electron of Y. Okay, then after that the X27, 3, 4, 5, 6, 7. So likewise you will have all this like this. Okay, so this would be the dot and cross diagram for XY. Covalent compound, the bonds are formed by sharing of electron. So the formula of this covalent compound of course is XY4. So XY4 is the answer. Of course for this question you don't need to draw the dot and cross diagram out, but if you draw the dot and cross diagram out, you can get a clearer picture of what the formula is. Okay, the next question is from the year 2009, Paper 1, Question 7. Now 25 cm cube of aqueous, 0.1 mole per dm cube of hydrochloric acid exactly neutralizes 20 cm cube of aqueous sodium hydroxide. The equation for this reaction is shown. What is the concentration of the sodium hydroxide solution? Now there are a lot of information given here, so it would be good to summarize the information. Sorry, it's a bit noisy for this video because there are a lot of kids playing at the playground. Now you have 25 cm cube aqueous 0.1 mole per dm cube hydrochloric acid. So it's from here. You have 25 cm cube, 0.1 mole per dm cube. This is the concentration, this is the volume. Exactly neutralizes 20 cm cube of aqueous sodium hydroxide. So sodium hydroxide 20 cm cube. Only the volume is given. The concentration you have to find. See, what is the concentration of the sodium hydroxide solution? Now, sorry, my son was shouting outside. Now, the balanced chemical equation has been provided to you, meaning that from the balanced chemical equation we can see that 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. Okay, so basically from this information here, it's okay. So theory wise is 1 mole to 1 mole. Now you have to find out from the experiment how many mole of hydrochloric acid is used. Now if you look at this volume, when you multiply the volume and the concentration, these two will cancel. Now when you look at over here, you have volume, over here you have volume. Now if I convert this volume to dm cube and then I multiply the volume and the concentration, these two volume will cancel off. So what is left is the number of mole. So meaning that if I multiply this and this, I'll get the number of mole. Okay, let's do it. Now 25 cm cube is the same with 25 over 1000. It is the same with 0.25 dm cube. Okay, so 25 cm cube is the same with, it's the same with 0.025 dm cube. Now I can find out the number of mole. How do I find out the number of mole? 0.025 dm cube times 0.1 mole per dm cube. When I multiply like this dm cube and dm cube will cancel off. What is left is 0.0025 mole. Now this is very important. The mole ratio for NaOH and HCl, the mole ratio according to the balanced chemical equation is 1:1. Now this is the theory. In the experiment I use 0.0025 mole of HCl. So likewise, if I use 0.0025 mole of HCl, I should use 0.0025 mole of NaOH. Okay, I should use 0.0025. Now we have 0.0025 mole, and then the volume, we know that the volume is 20 cm cube. Okay, so using this 20 cm cube and 0.0025, you have to find out the concentration in mole per dm cube. Now 20 cm cube, how many dm cube first? So divided by 1000, 0.020 dm cube. So you have the volume, you have the mole. Can you find out the concentration? So the concentration, again I apologize for the noise created by my son. I think they are too happy playing with each other. So the concentration would be your concentration mole per dm cube. Okay, the concentration required in the question is mole per dm cube. So mole per dm cube, the concentration, so there will be the number of mole. Mole per dm cube means the number of mole divided by the number of volume. So 0.0025 mole divided by 0.020 dm cube. So when you do this, when you find this ratio, the answer should be in mole per dm cube. 0.0025 divided by 0.02 is 0.125. So the concentration of NaOH should be 0.125 mole per dm cube. So the answer is C. Okay, this is a long question. Basically, from the balanced chemical equation, you should know the mole ratio. And then for HCl, the volume is given to you, the concentration is given to you. When you multiply the volume and the concentration together, you should get number of mole. But before that, the unit for the volume must be the same. That's why I change it to dm cube. Cm cube changed to dm cube, divided by 1000. Get the dm cube ready. So this dm cube, the volume, multiply the concentration, you should get the number of mole. Once you get the number of mole, you should know what is the number of mole for NaOH, because the mole ratio is 1 to 1 according to the equation, 1 to 1. So if you get 0.0025 mole HCl, you should have 0.0025 mole NaOH. And this NaOH, the volume is given to you 20 cm cube. Again, the concentration is mole per dm cube. So first of all, change this 20 cm cube to dm cube by dividing by 1000 dm cube. Then you take this ratio, number of mole divided by the volume, number of mole divided by the volume, that is the concentration. Now let's look at this question. Is from 2009, paper 1, question 8. The relative atomic mass of nitrogen is 14 and the relative molecular mass of ammonium nitrate is 80. What is the percentage of nitrogen in ammonium nitrate? Now, this question, a lot of students would simply take the ratio of 14 over 80 and then times 100. That is wrong. It's a trap. Now, percentage of nitrogen in ammonium nitrate. First of all, you need to know what is the formula for ammonium nitrate. So you know ammonium NH4 plus. You have to remember this. Nitrate ion, the formula is like this. Okay, again, this is ionic compound, one positive, one negative ion. So cross multiply, you should get NH4 NO3. So this is the formula for ammonium nitrate. Now the question say, what is the percentage of nitrogen? So you have to ask yourself, how many nitrogen are there? There are 2 nitrogen. So the percentage of nitrogen would be, there are 2 nitrogen, right? So 2 times the AR for nitrogen. AR for nitrogen is 14, divided by the MR for the whole thing. The MR for the whole thing. So the whole thing is basically just add up the AR for each individual element. You have 14 plus 4 times 1 plus 14 plus 16 times 3. And then percentage. So you have to multiply 100. So you should get 28. And then $80 times 100, and this would be 35%. Okay, so the answer is D.